almost a week ago, we had learned about Pythagorean theorem. What did I teach you about Pythagorean theorem? What's the first thing you need to do? Label. Remember, your C is always across from the 90 degrees. And then after that, it does not matter which one is A and which one is B. You can move them around or you can do the same. It doesn't matter. All right. And then remember, the formula for Pythagorean theorem is C squared equals A squared plus B squared. What is my C here? X. So I can just leave it X C squared, or I can put X squared. What's my A? 6 squared. And again, this is nowhere on your paper, you're just looking up. And what's my B? 4 squared. And then what do I do to get X by itself here? We square root both sides. And then you're just going to put this right here in the calculator. Do we agree that's what we learned on Friday? Remember, when you're putting it in the calculator, to include the square root and then include the parentheses. What was it? 6 squared and what? Don't forget, a lot of people are forgetting the plus in the middle. Don't forget the plus. And then it gives us a decimal this time. Starting today, we're going to learn how to handle these decimals. So this was 7.21. Okay? Right here, same thing. I'm still going to do C squared equals A squared plus B squared. But what's different about this one? I have C squared this time. So this time, I'm going to plug into C because it's 16. I don't have A squared, and I have B squared. That's an arrow. What did we say to do if you have C squared? You are going to subtract them. Make sure C always comes first. The bigger number needs to come first, or in your calculator it was giving us undefined. So the bigger number comes first, and then we just do the same thing as far as what? Square root. But this time there's a minus between them. So I would do 16 squared minus, was it 8? So this is 17 point. Oh, thank you. It is minus. So 13.86. Do I have any questions? Today we're going to move on, and we're going to start, instead of getting decimals, we're going to start doing radicals. So I gave you a couple minutes. Just as a reminder, a radical sign is what she liked to refer to as the check mark. This is a radical sign. Inside the radical is a radicand. What is a radical doing? Like, what is this square root actually doing? It is simplifying, but what is it? What's the operation it's doing, or how does it get an answer? Like, what is the square root of 16? 4. Why is the square root of 16 4? Like, why is that the answer? Because what square root is doing is it's finding the number that you're multiplying by itself. Or it's finding the number that is squared. Do you agree 4 times 4 is 4 squared? And do you agree a squared and a square root cancel out? So that is just 4. That is what the square root symbol does. Is it's finding the number that you multiply that's exactly the same, and it comes out. So we just did that. On your paper right here, hopefully you can do some of these without any help. Hopefully we know some of these by heart. Maybe you might need a Desmos after a little while. But what is 1 squared? 1. 2 squared? 3 squared. Be careful. 3 squared is actually one of the most missed, because a lot of times y'all tell me 3 squared is, what do you want to say? 6. 3 squared is 3 times 3, which is 9. One of the most missed. What's 4 squared? 5. And by the way, remember, why does it keep doing that? By the way, squared is multiplying by itself. It's saying, what is 2 times 2? What is 3 times... Goodness gracious. Okay. What is 4 times 4? So 5 squared is, what is 5 times 5? 6 times 6? 7 times 7? 49. 8 squared? 64. 9 squared? 10 squared is a favorite. 100. How are you? I like your bluey shirt.
Thank you. Sydney's wearing one.
11 squared? Miss Geometry. 12 squared is another favorite. We all love that one. I don't know why we do. Does anybody know 13 squared without using a calculator? 169. My boys tend to remember that. Does anybody know 14 squared? It's actually, you just flip these two. It's 196. So if you can remember 13 squared, 14 squared is just flipping them. 15 squared is 225, and then 20 squared is 400. These I would like you to have memorized. Your life will be easier if they're memorized. But are you always going to have Desmos in this class? Absolutely. So it's fine if you just use Desmos. All right. If you can do squared, can you do square roots? Yes. What is the square root of 400? 20. What is the square root of 225? Square root of 196. Square root of 169. And then so forth. Y'all catching the drift here? So please fill in the rest of this paper for me. Alright, so I want you to keep this in your back pocket, and every day this unit you're going to want to take this out because we are going to use this. So for right now, do not put this away. I want you to put it on the side of your desk, please. Don't read my emails. That's not what I want either. This is what I want. Alright, we just did that. So, we are going to start doing square roots today where you do not get a decimal, you get an exact answer. On the warm-up, I accepted that decimal. Starting today, I will not accept a decimal. So, I would like to give you a story time. And actually, if y'all can all, don't close your computers, but just dim or slant them shut a little bit. I'll have you open them back up in a second. But if you can, just a little bit, not all the way. All right, story time. There was an old woman who lived in a shoe. Yup. She had so many children, she did not know what to do. When they left the house, the wind would blow them away. So she tied the twins together and make sure they would stay. Do you see any twins? Who? My purple shirt girls. Cool. I heard the blonde hair. The green. The one with the floaty. And my lemonade boy. Is that it? Okay. Unfortunately, some children just didn't have a pair. So they couldn't go outside. They could not go anywhere. Under the roof, they watched as the twins played and played. So the wind wouldn't take them and they could be safe. So why did I tell you that story? Because in order to simplify radicals, we are going to be doing something called a factor tree. You learned about a factor tree when y'all were maybe 4th or 5th grade. So we're going to be doing a factor tree, and you are going to be finding pairs. When you find a pair, you are going to be putting them outside the radicand, a radical sign, and then with the ones that don't have a pair, they stay inside. So if you can please get your notes that you picked up and fold them like this. Fold them right here, please. We're going to go ahead and fill them out. So, pairs. Where did the pairs go? On the outside. Everybody write that down. Pairs go on the outside, and lonely numbers, or the ones by themselves, stay inside. Alright, so what gives me 75? How can I get 75? 25 times 3. And I want to preface with, there are many different ways to do the factor tree. The way that I am going to do them is not the only way. For instance, some of you might have said, hey, 15 times 5 works too. It does. You'll get the same answer no matter what two numbers you multiply. Alright? Do y'all agree 3 is a prime number? Do you agree 3 cannot be multiplied by anything else? So I'm going to underline it because 3 is a number we're going to work with. What about 25? Is 25 prime, or can I keep going? How can I keep going? 5 times 5. Can I keep going with 5? No, so underline them. And I'm going to X out 25 because we're done. Like, we used 25, we're done with it. Do you see any pairs? Please circle the pairs and box the one that's by itself. So my answer is, I have a pair of what? 5s. And who's all by themselves? So my answer is 5 square root of 3. Now, if y'all can please look up real quick. What we love about radicals is we can check them. Somebody told me, I can put this in Desmos, right? You can't, because Desmos will only give you a decimal. It will not give you an exact answer of radicals. However, when you get an answer, you can check, are these the same number? Then you know you got it right. So you can check if you're correct, but Desmos will not give you a specific answer. Does that make sense? Okay, let's try another one. The square root of 45. How can I get 40? Oh, and by the way, actually what I want us to do first is I always want to check this first, because make sure it's not a perfect number. Make sure it's not one of them on this paper. So let's do the square root of 45. Is that a perfect number? No, so we know we need to do our tree. How can I get 45? 9 times 5. Are either one of these prime? 5. I can underline 5. Prime meaning you can't go any further. So the only number I would get would be 1 and 5. If 1 is the only number you can get, it's prime, you're done. Yep. Can I keep going with 9? How can I keep going with 9? 3 and 3. And I use 9, so I'm going to cross it out, and I'm going to underline my 3's. Do I have any pairs? The 3's. Pairs go on the outside. And do you see how I'm only writing 1 3 on the outside? Don't write both. Who's all by themselves? The 5 goes inside. And before I box it as my answer, I'm going to check to make sure it is correct. So is 3 square root of 5 the same as the square root of 45? Yes. Now I can box it and move on. Are they always going to be this easy? Unfortunately, no. Can I move on to the next one? Next one's a little bit more complicated. 200, that's a bigger number. How do I get 200? I can do 100 times 2. 2 is prime. Is 100? How can I get 100? So this is where y'all might differ. Somebody might do 50 and 2. Somebody might do 10 times 10. It doesn't matter. You should end up with the same answer. Alright? I don't mind doing all the ones with 2's because it makes it easier, but it's up to you. How can I do 50? 25 and 2. And I'm going to cross out 100. I'm going to cross out 50. I'm done with them. How can I do 25? What's 25? 5 and 5. Cross out 25. And this is what I end up with. This is called a factor tree. I got all the main factors. Do I have any pairs? What do I have a pair of? I have a pair of 5s. I'm going to write 5. But I have another pair. Do y'all agree I have triplets? We don't want triplets. We just want pairs. So I'm just going to circle this pair of 2s. And what do you think I'm going to do with this 5 and this 2? Not square root them yet. I'm going to multiply them. So if you have more than one pair, you multiply them. Who's by themselves? The 2. And so remember, when he's by himself, we don't want him to blow away. He has to stay inside. What is 5 times 2? So this is 10 square root of 2. That is my answer. And then what did I tell y'all to always do? Check it in the calculator. If I have the square root of 200, does 10 square root of 2 work out? Yes. I want you to try this next one on your own. Go. What is 63? We're struggling? And if you're not sure, like you don't know even where to start, always divide by the prime number. So you could just do by prime number. So you could do, is 63 going to divide by 2? No. But could it divide by 3? So that's a way to just sit there, start dividing in your calculator to figure out what you got. Is it a perfect number? So I'm going to do 21 times 3. If you did something different, watch, you're going to get the same answer. Can I keep going with 21? What's 21? Huh? 7 and 3. And those are prime. Did anybody do this different? Did anybody do 9 and 7? That's fine. Watch. Can 9 keep going? 3 and 3. Do you see how it doesn't matter which way you did it? We ended up with the same 3 numbers. So you can do this many different ways. What's my rule? Why is 3 on the outside? Pairs go on the outside. Lonely guy goes on the inside. Pairs go on the outside. Lonely guy goes on the inside. And then last but not least, check your answer. What is 3 square root of 7? Are they the same? Yes. So we're done. Okay. Open up, please. 192. That's a big number, right?
Yeah.
Do you know what it divides by? I don't really know that number by heart, so I'm just going to sit here and divide 192. What can I divide by? The obvious. 2. It's 96 and 2. Do we know what 96 divides by at the top of our heads? If we don't, what can I divide it by? I can do it by 2 again. And it's 48 and 2. What is 48? And I like to do all the 2's on the right just so they're easy to circle. But it's up to y'all. It doesn't matter. 24 is... 12 is... And I can cross all these out once I have something under them. And 6 is... That one is a long one. What am I going to do here? Circle pairs of 2's. So I have one pair of 2's. 2 pair of 2s, 3 pair of 2s. And who's all by themselves? The 4 3. Why am I not going to include that 6 or the 12 or the 24? Yeah, those we already used them by doing the tree underneath. What is 2 times 2 times 2? Be careful. What's 2 times 2? Times 2? 8. So just be careful with that. 2 times 2 is 4. Times 2 is 8. And then again, always check yourself. Would I be so nice to give you a multiple choice question like this on the test? What could you do with a multiple choice question? Could you just check all the answer choices and see which one matches? Did y'all learn to do this in Algebra 1? Y'all were supposed to, but when y'all learned quadratic formula, but I don't know. Okay, you might have, but not for long. Alright, I want y'all to try 98. Do number 6 on your own. Go. Look up when you are done. Is that what y'all got? Is this making more sense? Okay. What we're about to do for these next two, I'm not really changing any, I'm changing one thing, but only one thing. What do you notice about the next two problems? It has an outside number. All that's going to do is change at the very end. We have to bring it down. We're going to do the same steps we've been doing, but at the very end, we have to worry about this 5. Okay? I'm not going to worry about it right now. Cover it up. It doesn't matter right now. How do I deal with 18? 9 times 2. What is 9? 3 and 3. Pairs go on the outside. Lonely one goes. Normally we would be done. Do you agree? But what's different? The 5 is going to have to do what? Multiply. What is 5 times 3? And you can still check your answer. Did that make sense what I just did, or did I go too fast? Not much different, right? Still check your answer. Are they the same? Okay, I want you to try the next one on your own. Go. Ooh, the next one might be tricky, actually. Okay. What's different? Oh, no, I said why. Why is this next one tricky? You can. Y'all look up. Actually, don't want y'all to do this on your own because it is tricky. What's there a pair of? Y'all agree there's a pair of 2s? What's by themselves? Do y'all agree there are 2 Lone Rangers? Hold on, ladies. Do y'all agree there are 2 Lone Rangers?
Yes.
Can they go outside? They're by themselves. They're not a pair. They're not the same. So both of them have to go inside. 2 things have to go inside. And you just multiply them. What am I forgetting? My 2 up top also needs to come down. So what is 2 times 2? And what is 3 times 2? So this is 4 square root of 6. And then check it. And by the way, you're always going to catch me checking just to make sure I don't make a mistake too. 4 square root of 6. Are they the same? Yep. We're good. Alright. For these, use the calculator. By the way, what is the square root of 15 squared? What happens here? And then what happens? What's check marking and squaring? They're opposites. They cancel each other out. What's the answer going to be? 15.
Oh, they do.
So just be careful with these, because I will tell you, most people who get this wrong, they don't type it in the calculator right. You have to do parentheses square root of 15, close it, then squared. The squared needs to go outside. I want you to try to do the next one. What is 4 square roots of 3 squared? Put it in the calculator. 4 square roots of 3 squared. Y'all look real quick. These are a lot of the wrong ways that you can do this problem. Look at how many different wrong answers I just got. If you do not type this in the calculator exactly like it has on the paper, it will come out wrong. The answer is the first one. Do you see how if you mess up, you don't put the parentheses, it's wrong. If you put the parentheses in the wrong spot, wrong. If you put the squared in the wrong spot, wrong. Alright, what this does, real quick, what this does is this actually distributes my squared to both of them. What is 4 squared? Watch. What's 4 squared? It's 16. They cancel out right there. So what's the square root of 3 squared? And that's why it's 48. I would just do this in the calculator though. But they don't cancel out because that squared has to go to the 4 out front first. Alright, we are going to glue this on to page 41. This is simplifying radicals. Glue it onto page 41. Can I get somebody to pass out glue to everybody, please? Simplifying radicals. Thank you, Alexa. All right, we have 15 minutes left in class. What I want you to do on this worksheet is you only have to do the evens. What do I mean by evens? 2, 4, 6, 8, 10, 12. Just the evens. Do them and turn it in, please. You're doing 2, 4, 6, 8, and 10.
Wait, what about 12?
And 12, sorry. 2, 4, 6, 8, 10, 12. Sorry, we're out there at 12.
Don't you dare run it.
12 is just a calculator. You can do that one now. Behave. So you're doing evens, please.